AP Chemisters, this is Mrs. Vanderlei bringing you Chapter 1, Section 8, Solving Chemical Problems. This is otherwise known as factor labeling or maybe dimensional analysis. This is a skill that will be helpful throughout the entire year. And these initial problems may seem kind of simple to start with. Things that you probably did in your first year chemistry class, but trust me, it's going to get more complicated as we go on, and if you know this skill, it will really help you. And the whole idea is that you want your units to cancel out. And how do we do that? Whatever unit's on top, you put on the bottom. Whatever unit may be on the bottom you want to get rid of, you put it, it on the top. And hopefully, you had a lot of experience with this last year when we did moles and grams and liters and a number of atoms and things like that. And we will do that again, but we'll do more with it in this following year. So please make a concentrated effort to learn the skill because it will pay off big benefits in the long run, okay? So how do we do this? To convert, you want to multiply your quantity by a conversion factor that cancels the undesirable unit, the unit you don't want, and put the desired unit in the numerator. So consider a pen measuring 2.85 centimeters in length. What is its length in inches? Now I know you probably had a little bit different how to factor label. I have always done it where I put question mark unit that you're looking for. That way you are focused, you know exactly what unit you need to end up with. If you don't, tell yourself initially what unit do I want, you may get lost in the shuffle there. So this is my focus. I want to get up inches when I'm all set, so I go question mark inches equals. Then write down your given. All right, so what you want equals what you're given. And notice you have centimeters here. Don't be lazy, write down your units. So centimeters are on top, you're going to put centimeters on the bottom so they cancel out. Just like in a division problem, 9 over 9 cancels out to 1, centimeters over centimeters cancels out to 1. So what the unit do you want? You want inches. The question is, do you know a relationship between inches and centimeters? Hopefully you all know that. It's 2.54 centimeters equals, that's what that bar is, like you're in equals 1 inch. Okay, so the centimeters cancels out, leaving you only inches on top. Well, hey, that's what you want, inches right here. And so life is good. And if it's in the denominator, so 2.85 is going to be divided by 2.54, and you get 1.12. I said, notice the given measurement determines the sig figs. This is unlimited. Remember that undefined, or I'm sorry, infinity, if you will. So there is no, you don't use your sig figs here. It's a definition. You only use your sig figs here. So I have 3 sig figs. My answer is 3 sig figs. All right, so the next one is how many centimeters are in 12.5 inches, all right? So what are you looking for in this case? You're looking for centimeters. So I would go question mark centimeters equals, here's my given, 12.5 inches. So what unit goes on the bottom? Inches. What unit goes on the top? Centimeters. Why centimeters? Because that's what I'm looking for right here. So my relationship is 2.54 centimeters equals, that's what the division bar is, equals 1 inch. Notice that the inches are going to cancel out. Here we go, inches canceled out. And what unit am I left with? I'm left with centimeters. That is what I'm looking for. And so I'm ready to do the problem. So now it's 12.5 times 2.54. 2.54 is on the top. So you're going to times it. And you get 31.75 centimeters. That's what my calculator gives me. So what would be my answer with correct sig figs? Well, go back to this number again. How many sig figs are in 12.5? You got 3 of them. So I need to round this to 3 sig figs. So you go 1, 2, 3. So I have to round up. My answer is 31.8 centimeters. Okay. So we're going to try some of these. You probably want this. Read it carefully because it may help you later. So problem number 27, convert yards into centimeters. Folks, this is more than what I call a one-stepper. You have to do a couple steps here. So why don't you pause this, check it out when you're done. All right, so go ahead and pause. Okay, so let's see how you did. So convert 1.76 yards to centimeters. So I'll put question mark centimeters, that's what I'm looking for, equals my given. Now what unit do I not want? I don't want yards, so I put it on the bottom. Now I know a conversion in yards and inches. There's 36 inches in a yard. That would get it to me. Maybe you actually used that because you knew there were 36 inches in a yard. I'm not sure. But I went up here, and you see this right up here? I actually used this where it says 1 meter is 1.094 yards. So here is that. So my yards ends up canceling out. And then what? Well, I have meters left on top. Do I want meters anymore? No, I don't. I don't want meters. I want centimeters. So guess what? I put meters on the bottom and I put centimeters on the top. So what's the relationship between meters and centimeters? It's not up here, nor will it be. You got to know that. Which is a bigger unit, a meter or a centimeter? A meter is, so it gets the 1, and centi means 100. So now I'm ready to actually, go through the problem. All my units are working out great, so now it's a matter of using my calculator. So I get 1.76. This is in the denominator, so you're going to divide by 1.094. This is on the top, so I'm going to times, and this is what my calculator gives me. Now that's not the right answer, is it? You got to use your sig figs. So how many sig figs are, right here? I think it's 3, so I need to go 1, 2, 3. So what does this 8 mean? I need to round up. And so my answer is, don't forget your units, 161 centimeters. Okay, so why don't you go ahead and do the next problem. Pause this. All right, so I don't know if you know your relationships with quarts. All right, so we have how many cubic centimeters are 1.8 quarts. Quarts go on the bottom. I don't know anything about quarts. I know there's a couple quarts in a gallon, but that doesn't help me. So I go over here to volume, and that didn't help. But oh, look at this. All right, that helps me. So I have 1 liter is 1.057 quarts. So I use that to come up with this relationship. And then liters had to go on the bottom because I don't want liters again, right? So I'm going to cancel out here. I'm going to cancel out some quarts, cancel out some liters. And cubic centimeters are now on top, which is what I want because I saw that relationship over on that chart. And so, whoops, sorry guys. That works out, this cubic centimeters that I want. And then I'm ready to do my math. So 1.8. Divided by 1.057 times 1,000, and this is what I get. But how many sig figs are in 1.8? Only 2. So now I need to count over 2 sig figs. I have 2 sig figs. And what happens then? I need to stop here. So it's not 17, it's just 1,700. These zeros are not significant because I didn't, that zero is not going to be significant, 2 sig figs. So I get 1,700 cubic centimeters. Now, what's a little bit different about this next one? I want you to change it for me. The speed limit in highways is 65 miles per hour. What would be the number posted in kilometers? Change that to minutes, okay? Whenever you have a unit that is split into a numerator and a divider like miles per hour, all right, I would write it out where it's not like a slash, it's an actual fraction. So kilometers over minutes is what you're looking for. You're given miles per hour. And what you're going to have to do is work with both the numerator and the denominator. So what I did first is I went ahead and worked with the miles. So I found miles and put miles on the bottom. And if you looked at the top part up here, do you know a relationship between miles and kilometers? And the answer is yes, right here. So I do know a relationship between miles and kilometers. So I put 0.6214 miles on the bottom because that's where my unit was, and 1 kilometers on top. Hey, guess what? Isn't kilometers what I'm looking for? For the top it is. Yeah, sure. So my numerator is all taken care of, but what about my denominator? All right, what about my denominator? Well, I need minutes on the bottom. Well, what do I already have on the bottom? I have hours. So I don't want hours anymore, so I have to put hours on the top. That's right. So then you have minutes in the denominator, and that's exactly what I want. So life is good. I'm ready to do my math. So it's 55 divided by 0.6214 divided by 60 again. And this is what I get in my calculator. How many sig figs are right here? I think there's 2. So I go 1, 2. This is a 7. So I need to round up to 1.5 kilometers per minute. Okay. All right. Let's go to the next page. So what happens if you want to raise units to a power? Okay. You have to raise both the number and the unit. So if you want to convert inches to centimeters, I know that 2.54 centimeters is 1 inch. So I'm going to square both sides. And when you square both sides, you square both the number and the unit. Okay, you square both the number and the unit. So 2.54 squared is 6.45 cube or squared centimeters equals, well, 1 squared is still 1 squared centimeter. All right, so what are we going to do here? Calculate the displacement of 5.70 liter engine, there we go, to cubic inches. Well, how are we going to do this? Well, I'll help you out here. 5.70 liters, I put liters on the bottom and cubic centimeters on top, so my liters cancels out, so now I have cubic centimeters. I don't want cubic centimeters, I want cubic inches. So I kind of wrote it out 3 times. That forces me to divide by 2.54 3 times, or in a sense, cubing it. I've been teaching a very long time, and people that just cube, on the bottom will on occasion forget to cube the number. So when I write it out 3 times, I am not forgetting to do that. So what happens, this is a cube, and here's to the first, to the second, and then to the third. So I do cancel out these units, and inch times inch times inch is inches cubed. All right, so just a matter of doing your math. So 5.70 times 1,000 divided by 2.54 divided by 2.54 divided by 2.54, and this is what I get here when I do that math. And again, I have 3 sig figs, and so I go 1, 2, 3, and I have to round up, so 348 inches cubed. Okay, why don't you do this on your own? Pause and check your work. All right, welcome back. Let's see how we did. So here we have meters squared, and I want squared centimeters. So 1 meter is 100 centimeters. Again, remember your units. The bigger unit gets the smaller number. The smaller unit gets the bigger number. So 1 meter is 100 centimeters, but I had to do that twice because this is squared. So here's the first, here's the second. I want squared centimeters, so centimeters to the first, and centimeters squared, so that works out. So this is what I get. Now, what's wrong with this answer? Mrs. Vanderwall, you forget about sig figs. Well, you're right. So how can I fix this? So I have 1, 2, 3 sig figs. I have 1, 2, 3 sig figs. So put a line over the 0, the first 0 to give you 3 sig figs. Well, how else could you have done this? You could have used scientific notation, and you could have said 1.20 times 10 to the 5th. And that would be also 3 sig figs, but the line works just as well. Okay, so what's going on here? So we can go back to our old buddy density again, all right? So the density of a diamond is grams per cubic centimeter. If the volume of a diamond is found to be 2.8 milliliters, what's the mass? Well, mass is grams, isn't it? So really you're doing question mark grams, all right? You can do that. And then here is my density. And notice that cubic centimeters are on the bottom. Put cubic centimeters on the top. That's my volume, isn't it? So density times volume. The cubic centimeters cancels out, leaving you grams, and that is the unit of mass. And so here is my work. Why don't you go ahead and do the next 2 problems, pause this, and see how you do. Well, maybe that took you a little bit. Maybe the letter C took you a little bit. Maybe letter B didn't. So it's just, again, a unit of canceling things out. You are maybe not familiar with what a caret is, but you can still factor label. And so the carets cancel out. Notice how you spell that, caret, not like the vegetable. And then grams goes on top. I don't want grams. I want cubic centimeters. So once again, I used my density. I put mass on the bottom because that's what cancels out. Put my volume on the top. And so again, with 2 sig figs, this is what I get. Now look at letter C. I kind of like letter C because what is the length? Well, Mrs. Vanderwall, nothing in here gives me meters. All right, what am I supposed to do? Well, you do have volume. And if it's a perfect square, perfect cube, if you will, that's what I'm assuming when it said a perfect square diamond there. This is my volume of 0.11 cubic centimeters. Well, all I did is I took, in a sense, the cube root. I couldn't really type cube root out very well, so I made it to the 1/3. Same thing as saying the cube root. So here, the same thing as saying the cube root of this. And I just, took the cube root of 0.11 and I found 0.48 centimeters. So this perfect 2-carat diamond that's a perfect cube is 0.48 centimeters. Okay, and I believe that's the end. As always, don't wait to be great. Bye.